So you are watching this video for one of two reasons. Either you're in class and you're checking your answers and you'd like to see how things work, or you're not sure how to do something, or you're outside of class, quarantined, and you're trying these on your own at home and you're checking your answers that way. So I'm going to walk through them the same way either way, and I'm going to start with the blueberry farm. So the key here is they offer 6 pounds of blueberries for $16.50. So you know when you buy things like blueberries or strawberries, it tends to be what's called a proportional relationship, which means if you buy 6 pounds for $16.50, you would expect just to double the price for 12 pounds. The other key here is that they tell us we're working through proportional relationships. So you're going to say, well, 6 pounds, it's clear they're counting by fives. So 6 pounds will be just a little bit after 5, and $16.50 is going to be somewhere in between this 12 and 24. They're counting by 12s, so you have to do a little bit of estimating. So that is not the best, but you do your best with the estimating. So you say 6, $16.50, so maybe around here. So here is your cost, okay? So you know that if you buy no pounds of blueberries, it would be 0. Another key thing about proportional relationships is that they go through the origin. So you could say, basically, I'm going to go and continue on up as I get through pounds of blueberries. Now, you'd be correct if you remember that maybe at a grocery store, they sometimes offer you discounts as you buy more. Typically at a farm, they don't. They have a price. So if you go to a farm, it will be a certain amount. But sometimes, like at Indian Creek, they'll offer you a deal for buying more peaches, for example. Okay, so that's what we'd be looking at. Let's look down at Priya. This is our second problem. Priya jogs at a constant speed. So that's your key, constant, the same. The relationship between her distance and her time. Well, let's find distance. It would be right here. And her time, I'll switch colors. Notice that's in hours, and her distance is in miles. So we're talking about jogging, and her time, as it's going up by tenths of an hour, her distance is going up. Notice it's going, here we have 2 miles, 4 miles, 6 miles. It's not a very large rate because she's running. Diego also bikes at a constant speed, but he's twice as fast as Priya. So you would imagine, I'll use green for Diego. He starts at 0, and notice that Priya after 0.1 is halfway between this marking, so he is twice as fast as her, so he's going to be all the way up. He's not just halfway up, he's all the way up. And now, so in 0.1, let's just think about what's happening here. In 0.1 miles, Priya has gone, well, this is a 1, right? She's gone half, or in 0.1 hours, Priya's gone half a mile. Well, in 0.1 hours, Diego has gone 1 mile. In 0.2 hours, Priya's gone 1 mile, so Diego should have gone 2 miles. In 0.3 hours, Priya has gone 1.5, so Diego should have gone 3 at this point. He's going up quite a bit faster than her, so 2 and then 4, and then 2.5 and then 5. Look at that. They're not staying exactly the same. So 3 and then 6, and then we're going to get to 0.7, which is 0.7 of an hour, and 3.5, but he's all the way up to 7. So you can see the trend line there. Diego is going up significantly faster than Priya. Let's go to our next page. So here is a graph between calories and grams of fish. Okay, so if you're anything like my kids, you don't like fish, but I know a lot of kids who love fish. My children do not. It says write an equation. Well, the first thing I want your brain to think is, this is a line. Y equals mx plus b. All I need to do is find my y-intercept. I need to put that I there, and my slope. Well, the y-intercept is right where it crosses that y-axis. It crosses at 0. So you can say to yourself, well, my y-intercept is 0. I don't need to write the 0, but I'm going to, just to keep myself honest that I know I found it. And remember, your slope is your rise over your run. So I'm going to pick a spot where it goes through perfectly. I can pick another and look at all those places where it goes through perfectly. So I'm going to be counting up from 0, and it looks like we're counting by 50s. So I'd be going up 150 on this blue. So I'll just make a note, oh, I'm at 150. And at the same time that I go up 150, I'll switch to red. My run looks like we're not counting by 50s, we're counting by 25s. So note that difference in scale. So here my run, I'm only going over 100. So my rise over my run is 150 over 100. In fact, let's keep my colors correct there. My rise is 150. I can cancel out the zeros and I'm left with 15 over 10, which would reduce down. 5 goes into 15 3 times and into 10 twice. So my equation for this is y equals 3 halves x plus 0, which I will simplify down to just 3 halves x. It's proportional because it's a line that starts at the origin. Now it says use your equation to complete the table. If you're in the classroom, you have your calculator. If you're at home, you can use a calculator tab, you can use your phone, whatever works for you. So your grams of fish is your X line. This is our X line. So I'm going to call this X, and your number of calories is your Y line. So remember, your equation is y equals 3 halves x. And it says, when you have consumed 1,000 grams of fish, how many calories is this? Well, your equation is 3 halves times x. So you would do 3 halves times 1,000. Go ahead, reach for your calculator, or you could put the 1 underneath your 1,000 and do your cross canceling. 2 goes into 2 once and into 1,500 times. Then you just multiply across. 3 times 500 is 1,500. So 1,000 grams of fish is 1,500 calories. So here, when you're given, I'm going to jump down to this last one. If you have 1 gram of fish, it's 3 halves times 1. Well, 3 halves times 1 is just 3 halves. That would be kind of a small amount of fish, 1 gram of fish. And now if you have 2,001 calories, we're going back the other way. So you would say your y value is 2,001. So I'm going to put this off to the side. I'll say y equals 3 halves x. And I'll say 2,001 equals 3 halves x. This is where I typically find out that kids have forgotten about the reciprocal. So I'll remind you that you would multiply by 2/3 on both sides. When you do that, something times its reciprocal cancels out and you're left with x equals, and here I would just snag my calculator or do this in my head. I would do 2 times 2,001, so 2,001 times 2 gives you your 4,002, and you divide that by 3. Divided by 3, we come up with 1,334 equals x. That represents the number of grams of fish that gives you 2,001 calories. That one's a tricky one. Let's look at our last page. This is our most real-world example. A contractor must haul a large amount of dirt to a work site. She collected information from 2 hauling companies. So they didn't give us the contractor's name. So this one is Easy Excavation, and it gives its prices in a table. So if you buy 8 cubic yards of dirt, the cost is $196. If you buy 20 cubic yards of dirt, the cost is $490. If you buy 26 cubic yards of dirt, the cost is $637. On the other one, this Happy Hauling Company gives its prices on a graph. So if you buy 0, it's 0, and the next spot where it's perfect is 1 cubic yard of dirt, and you can read across that it's 25. And 2 cubic yards of dirt, it's linear, it's proportional, is 50. So it says, how much would Easy Excavation charge to haul 40 cubic yards of dirt? Well, Easy excavation is right here. They've given it in a table and they don't have an answer for 40. So I'm going to build my table out and I'll put a spot down here and I'll just make darker lines so that they all look nice and the same. And I'll jump up to 40. So what I'm going to notice is that from 8 to 20, I'm increasing by 12. And then from 20 to 26, I'm going up by 6. What am I going to need to do to go up to 40 is what I want to start to think about. So I'm going to have to go up by 14. So that gets a little bit tricky. It's not really following this pattern. So I'm looking, I don't really see a pattern happening. So one thing I notice is they've given it prices in a table. They have not actually said that it is proportional for this one, but it is implied that it's proportional. And I can check and see if it's proportional. So I'll take a look, 196 to 490. So you would say, well, what did they do to get from 196 to 490? And I would see that they have added 294. So plus 294. And then when we've gone up by 6 on the left with the X to get to 637, I'll just subtract 637 minus 490, and I'll see that we go up by 147. So remember that this is our X and this is our Y. And remember that slope is rise over run, which is also the change in Y over the change in X. So if I do 294, my change in Y, divided by X, which change in X is 12, I would do 294 divided by 12, and I would end up with 24.5. So 24.5 would be 2450 is my slope. That would mean my cost per 1 cubic yard of dirt. Let's check and see what 147 divided by 6 is. So 147 divided by 6 also gives me that 2450, which we know because it's the proportional relationship. So what I would need to do is say, well, I know that it's going to cost 2450 per each cubic yard of dirt. So I would do 40 times 24.50, and I would end up with $980. So how much would they charge? They would charge $980. I've explained it and I've shown it. This is my per cubic yard. Now calculate the rate of change or slope for each relationship. Well, we already did that on the first one, so easy excavation is going to be 2450. And here you can read it from the graph that for 1 cubic yard of dirt, it's $25. So for happy hauling, it's 25. That would be our rate of change or slope. What does it mean? That's your price per cubic yard. And now it says if the contractor has 40 cubic yards of dirt to haul and a budget of $1,000, which company should they hire? Well, we now know that the first company charges $980. We don't know what the second company charges, but we do know that it's $25 a cubic yard. So I can quickly say 25 times 40, and I would say 25 times 40 would give me 1,000. So I feel like this question is kind of a silly question because I would probably say $980 is a better choice for my 40 cubic yards, and now I could go and buy myself something extra. But if you're meaning that you should pay exactly 1,000, then you would go with happy hauling. My guess is that everyone will answer differently here, but we'll answer that the first company is 980 and happy hauling is 1,000. My choice would be this one, and I'd go buy myself lunch. So that wraps up these problems. We may not get through all of these in class, and we may carry this into tomorrow. It will depend on how our class has gone. So like I said, you're either watching this because you're in class or you're watching this because you're at home. And if you're at home, you might be just using it as a lesson. If you're in class, you're working with your partner to try it first. Or if you're stumped, you're using it as a lesson.